Hello students and welcome to my channel Maths Up. So in this video, I will be talking about volume in multiple integrations, right? So if you haven't watched my previous video, do watch them to check out what is multiple integration all about. And in my previous video, I talked about how to calculate the area of any surface in multiple integration, right? So let us understand the concept of volume of a surface. Now, when we are calculating the volume of a surface, for example, if I have a cuboid, it will have three dimensions, that is x, y, and z. So a small change in x is denoted as delta x, a small change in y is denoted as delta y, and a small change in z is denoted as delta z, right? So now, so here, the formulation for volume is given by triple integration dx, dy, dz. And so when I calculate volume, we get a triple integral over dx, dy, dz. So again, the order of integration matters. So when you are writing dx, dy, dz, that means the inner integral depends on x, then the next one depends on y, and the last one depends on z. So as you keep this order, so you can write here dy, dx, dz also, you can write dz, dy, dx. So whatever way you are writing the variables, similar way we have to do the integration, right? Now, in my previous video, I also talked about how to convert Cartesian system to spherical polar system or to cylindrical coordinates. So in a similar way, we can also convert volume using spherical coordinate system or cylindrical coordinate system, right? So if I want to convert volume or Cartesian system into polar coordinates or spherical polar coordinates or maybe cylindrical coordinates, we have a different formula for volume. So how can we derive that? So if I'm doing calculating volume using the cylindrical coordinates, then volume becomes triple integral r dr d phi dz, right? So what are these dimensions? How did we get this? Since volume is equal to triple integral dx, dy, dz, so what will happen when we are using cylindrical coordinates? We know that x is equal to r cos theta and y is equal to r sine theta and z is equal to z, right? So since I'm writing here phi, so I'll just use the angle as phi here. So now when we know that whenever we are converting Cartesian system to cylindrical coordinates, what happens? Jacobian is basically r only, right? So when Jacobian is r, what will happen? Dx, dy, dz will get converted to r, dr, d phi. And this volume will get converted to, so this will change and we will have here r, dr, d phi and dz will come as it is, right? In a similar way, if you remember, we did converting Cartesian system to spherical polar coordinate system. So there the Jacobian of transformation is r square sine theta, and so dx, dy, dz will get converted to r square sine theta dr d theta d phi, right? Okay. And similarly, we also know that mass is equal to volume into density. So whenever we have to calculate the mass, so we will be multiply density with the volume of that surface, right? So here rho denotes the density of that object or of that body. So now let's come to the first question. Use triple integrals to find the volume of a tetrahedron bounded by the four planes x equal to 0, z equal to 0, x equal to 2y, x plus 2y plus z is equal to 2. So you can very well see that the question involves the Cartesian coordinate system. So we will try to calculate the volume of this tetrahedron using the Cartesian system. So according to the Cartesian system, we know that the volume is triple integral dz, dy, dx, right? So normally what happens when we are doing the questions of volume, we have to, imagine what would be the surface because it would be a little difficult to draw all these figures. So what we will do, we will try to figure out what are the parameters for z or what are the limits of z, right? So you can see that z is equal to 0 here, right? And there is one more plane, that is x plus 2y plus z is equal to 2. So from the equation of the plane, we will get that limits of z lies from 0 to, from here, we will calculate the value of z. So z will come out to be 2 minus x minus 2y. So we will get the limits of z as 2 minus x minus 2y, right? And now once we calculate z, so when we will solve the inner integral, z will go off and we will be left with the surface x equal to 0, x equal to 2y and x plus 2y is equal to 2. So these are the three surfaces left, right? Now when these three surfaces are left, we can plot this in a 2D, right? And when we plot this in a 2D, we will get this. This is x equal to 0, the y-axis. This line is x equal to 2y. And we will get this line as x plus 2y is equal to 2. So from here, we can see that the common portion is this triangular region, right? So when we get this triangular region, I've already told you how to calculate the limits. So what you can do is you can just take a strip to calculate the limits of y. You can take a strip here parallel to the y-axis and we can check out what are the inner and the entry and the exit points of the strip. So you can see that the entry point of the strip is this line. So on this line, the value of y is always x by 2. And the exit point is on this line, and on this line, the value of y is always 2 minus x divided by 2. So it is 2 minus x divided by 2. And finally, to calculate the limits of x, we will check out the minimum and the maximum value. So the minimum value is 0. And when you calculate the intersection point of these two lines, you will get the intersection point as 1 comma half. So the minimum value of x is 0 here and the maximum value of x is 1 here. So the limit of x is from 0 to 1, right? So now let's calculate this integral. So we have 0 to 1 integration x by 2 to 2 minus x by 2, and we will get the inner integral as z, and when we put the limits of z, we will get simply 2 minus x minus 2y minus 0, so it will have no significance, and then we will be left with the integral dy dx. So now this is 0 to 1 integration with respect to y. So we will have 2y minus x into y minus 2y square by 2. So 2 cancels and we will get y square. The lower limit is x by 2. The upper limit is 2 minus x by 2 dx. Right? Now let us solve this. And when I put the value here, I get 0 to 1. 2 times, I'll put the limits in y. So I have 2 minus x by 2 minus x by 2. Then we have minus x times y again. So it is 2 minus x by 2 minus x by 2. And then we have 2 minus x by 2 whole square. So I will get 4 plus x square minus 4x divided by 4. This is 2 minus x whole square minus x square by 4, right? And the whole we will integrate with respect to x. So now let us open up all the brackets. So we have integration 0 to 1. Then we have 2 times. Let's solve this. 2 will be the common LCM. So I will have 2 minus x minus x. So that is 2 minus 2x by 2. So 2 and 2 will get cancelled and I will get simply 2 minus 2x, right? Now in this I will get, I'll just solve it here. I will have 2 minus 2x by 2 multiplied by x. So you can see 2 will get cancelled and I will be left with minus x plus x into x would be x square, right? So this is the term that I will get. And then let us open up the brackets over here. So when I open up this bracket, I will simply get 4 plus x square plus minus 4x minus x square divided by 4. So x square cancels and I'll get these terms. So I will have the terms minus 4 by 4 would be 1, and then minus into minus would be plus, and 4x by 4 would be again x, and I will integrate it with respect to dx, right? So these are the terms that I will get. Okay. Now let us finally integrate this, or let us solve up first. 0 to 1. So I have x square minus x and plus x will get cancelled. I have 2x minus 2x, and 2 minus 1 would be 1. So this I can simply write as 0 to 1. This is x minus 1 whole square, right? So I can write this as, after integrating, x minus 1 whole cube by 3 and limits from 0 to 1. So now when I solve it, when I put 1, 1 minus 1 would be 0, minus, when I put the lower limit 0, I'll get minus 1 cube by 3. So that would be simply 1 by. So the volume of this tetrahedron would be 1 by, right? Now if I show you a figure for this tetrahedron, the figure would be similar to this. So this is my x, y and z plane. This plane x plus 2y plus z is this one, this triangular portion, right? And you can see that this plane, this is x plus 2y, x is equal to 2y. And you can see that this point of intersection of the plane and this vertical plane x equal to 2y is 1 comma half comma 0, right? So this is what a tetrahedron looks like. And so this is little, you just need to visualize it. So it is better that you just plot one of the coordinates, especially z. Once you plot z, the other two variables are in 2D, so you can easily plot them and you can get the values of x and y, right? So I hope this question is clear to everyone. So let us move on to the next question. So in the next question, it says that find the volume of the region that is inside both the sphere and the cylinder x square plus y square equal to 9. So let us first try to visualize it. So there is a sphere and there is a cylinder. So you can see that the radius of the sphere is 5 and the radius of the cylinder is 3, right? So if I just plot it, I will see that this is my x, y and z coordinate. So my cylinder is on the xy plane, so the radius is 3. So this is what the cylinder looks like. And the sphere has radius 5, so this is the shape of the sphere. So I have to calculate how much volume is contained inside both of them. So since the question involves sphere and cylinder, I would prefer to do this question using the cylindrical coordinates, right? So in the cylindrical coordinates, we know that the volume is basically triple integral r dr d theta dz, right? So now, instead of taking this order, I will take the order as dz, dr, d theta, right? That would be more comfortable for me because I will first fix the limits for z, then I will fix the limits for r, and then I'll fix the limits for theta. Now, how to fix the limits of z? So z is only involved in this one. So I have x square plus y square plus z square equal to 25. So what I will do is, when I'm converting this into cylindrical coordinates, I know that x square plus y square is always equal to r square. So I'll get r square plus z square equal to 25. So from here, z square is basically 25 minus r square. So since I can see that z is varying on both z positive and negative z axis, so the limits of z would be from minus under root 25 minus r square to plus under root 25 minus r square, right? Now, once the limits of r have been defined, z have been defined, let us calculate what is r. So this equation is all done. So we pick up the next equation, that is x square plus y square equal to 9. So I get r square is equal to 9. So r comes out to be 3. So the maximum radius of both the region is 3. So r goes from 0 to 3. And since it's a sphere, so the theta parameter will revolve from 0 to 2, right? So now let us integrate this. So this is 0 to 2 pi. Let us integrate the inner integral. So we will get 0 to 3. So r is a constant. So integration of z is z only. And when you put the limits, you will get 2 times under root of 25 minus r square. This minus minus this, right? Dr d theta. So now let us integrate this. So when you integrate this, I can simply put r square equal to t. So I will have 2r dr is equal to dt. So when I put back the value as t, so what will happen? So 2r dr will become dt and this will become 25 minus t dt. And what are the limits of t now? When r is 0, t will be 0. When r is 3, t will be 9. Right? So now let us integrate this. This is 0 to 2 pi. Now this is simply a linear equation. So 25 minus t raised to power half will be integrated as raised to power 3 by 2 and 2 by 3 will come as it is. Limits from 0 to 9 d theta. So this is 2 by 3 integration 0 to 2 pi. 25 minus 9 is 16. 16 raised to power 3 by 2. So I can write this as 4 square into 3 by 2. So 4 cube. So that is 64. So I will get the upper limit as 64 minus, when I put the lower limit, it is 25 raised to power 3 by 2. So that will become simply 5 square into 3 by 2. So that is 5 cube, which is 125 into d theta, right? And now when I solve this, I'll get, so I'll get from here 2 by 3, 61 negative, and then integration of theta would be 2 pi. It will be theta, and when you put the limits, you will get 2 pi. So since we will take the modulus of it, volume cannot be negative, so it will become simply 61 into 4, so that is 244 pi by 3, right? So this would be the answer. So I hope you understood this question, how we did the volume of this region using the cylindrical coordinates, right? Okay, so let's move on to the next question. So in the next question, we will be calculating the volume bounded by the cylinder x square plus y square equal to 4 and the plane y plus z equal to 4 and z equal to 0. So again, we will try to figure out the volume of the cylinder using the Cartesian system, because here you can see planes are involved, and again you can figure out the limits for z, and then you can plot it in x and y system and calculate the limits of x and y. So if I show you the figure, it will be similar to this. This is the cylinder in the xy plane, x square plus y square equal to 4, and it is cut by the plane y plus z equal to 4 and z equal to 0. So z equal to 0 is this. So this is the plane. So it will not extend on the negative z axis, right? Okay, so let's try to figure out the volume. So the volume is, again, I'll try to take the order as dz, dy and dx. So since z, the lower limit is 0, I'll take z as 0, and from here I can calculate z as 4 minus y. Now, so this equation is almost done. So now I am left with the equation of the cylinder. So to calculate the limits of y, I can write y square as 4 minus x square. So y would be plus minus under root 4 minus x square, right? So the limits of y will be from minus 4 minus x square to plus 4 minus x square, right? And once y is done, to calculate the limits of x, x square will be 4. So x is equal to plus minus, right? So x will go from minus 2 to. So now let us try to solve it. So I have minus 2 to plus 2, the limits of x. I have under root minus under root 4 minus x square to under root 4 minus x square. When I integrate the inner one, dz, I'll get z. And when I put the limits, I will simply get 4 minus dy. So now this is minus 2 to 2. Now when I integrate with respect to y, I'll get 4y minus y square by 2, limits from minus under root 4 minus x square to under root 4 minus x square. Let us put the limits here. So this is minus 2 to 2, this is 4. Now when I put the limits, I will get under root 4 minus x square minus minus of this. So that will become twice. So this is 8, right? And then when I put the limits here, I have 1 by 2. This is 4 minus x square, under root whole square. So square and under root will go minus. This whole square is again 4 minus x square, right? So these two terms will get cancelled. And I have integration with respect to x. So I can take out 8 common. Now I have minus 2 to 2 under root of 4 minus x square dx. So this is basically 8, and when I integrate this, I'll get x by 2 under root 4 minus x square minus a square by 2. So a square would be 4 by 2 sine inverse x by a. Limits from minus 2 to plus 2. So now when I put the limits in this, what do I get? I get 8. Now the first term, this is half. Let's put the upper limit. So 2 will make it 0. And when I put minus 2, that will also make it 0. So in the next term, I have 2 common. So let us take out 2. Now sine inverse 2 by 2. Sine inverse 1 is pi by 2. Then I have minus. Then I will have again sine inverse minus 2 by 2. So that is again minus pi by 2. So pi by 2 plus pi by 2 is pi. So that will turn out to be 16 pi. Right? So this would be the answer. Clear? So I hope you understood how to calculate the volume of any surface. Right? Okay. So if you have any doubt, do let me know in the comment section. And if you like the video, do hit the like button. And if you haven't subscribed my channel yet now, please subscribe it. And do believe in yourself and have a nice day. Thank you so much.